seem to get old. It's called an annuity. Okay? Now, an annuity is simply a fixed payment. It's fixed, meaning it's always the same. It's payment made or received on a regular schedule. I would rather be receiving payments on a regular schedule than paying. Yeah, it could be like a check. If you are renting a place and it costs $1,000 a month, every month it's $1,000. That $1,000 is considered an annuity. What people normally call it just, it's the rent check, it's how much you pay for, living space. But in the financial world, when you hear the word annuity, you're watching TV and they're talking about stock markets, annuities, blah blah blah. It's a payment made or received in a regular schedule. Okay, and it's fixed, it never changes. Some examples would be rent check, retirement funds, like teachers have retirement funds here in New York State. When you retire, you set so much aside that they pay you so much, even after you retire, a week, which is nice. So that would be an example of an annuity. We mentioned rent. If you're renting a place and paying, it's an annuity. But if you're the landlord and you're getting $1,000 a month, that's nice. That's an annuity too, if you're receiving it. Loans, mortgages. Man, you guys are all going to get used to seeing that. We'll talk about that later, and that's going to be some eye-opening stuff. But, yeah, that's what it is, all right? So, let's look at present value. I think we'll get through present value today, and then next class we'll do future value. But present value is just loans, mortgages, payments, etc. There is this equation. Okay, you ready to write this down? Yeah, it looks crazy, but it isn't. It looks crazy, but it isn't. All right? It looks complicated and crazy, but yeah, craziness, huh? All right? So we will go over this in detail, and you will see that you're familiar with most of all these, especially the number one. You're real familiar with the number one, okay? So, what do you think PV stands for? Present value. No shame in that. Present value, okay? Now, keep in mind, this is not a lowercase r like rates. It's an uppercase R. You can consider it like rents, maybe. So that's actually the payment in dollars. Not the total dollars, but the payment in dollars. For example, if I pay $1,000 a month, my R isn't $12,000 for the year. It's the $1,000 month. That's the steady payment. Okay? That's R. All right? So, present value is what we're solving, right? Capital R, it's nothing. Not a big deal. That's just what your payment is. I is rates. Well, we know what rate is from our bank equations, right? That's our percentage, right? Right. Over the number of payments per year. Does anybody know where that might have come from? Have we seen that before? What letter that might be? Yeah. What'd you say? It's K. Remember, something was quarterly, it was 4 times a year. Something was monthly, it was 12 times a year. So really, we've seen those before. It's R over K. All right. And M isn't difficult at all. It's simple math. I'm telling you, it's crazy. M would be the number of total payments. That's it. So if I'm renting your apartment, you're a landlord. I come to rent. I say, yeah, I'm going to sign a lease for 1 year. How many payments am I making to you? 12. Well, yeah, if it's monthly, yeah, I didn't explain that. Yeah, I pay you monthly. Yes, so I meant M will be 12. That's it. So is there really anything complicated here? No. We know I, R over K. R, that's just the payment. That's kind of important. This is what we're solving for, the PV, present value. I mean, M is just the total payment. So let me ask you this. If you are going to buy a car, and you're going to borrow money for it, and you're going to pay monthly on that car, for 5 years, what would be the total payments? 60, because 12 payments a year for 5 years. 12 plus 5, 6, that's it. So it's just simple math, all right? Now, yeah, well, wait until this. Let's start with the house before we get to the car, because that's going to be the mind-blowing thing, all right? So, what is this used for? All right. Let's use the equation, then we'll apply it to our house. You have a friend who wants to borrow $300. You ready? I promise you what? I'll give you 300 back, but I'm on that. I'll give you $100 this year, $100 next year, $100 after that. Okay? Okay, 100 at the end of the first year, 100 at the second year, and last, 100 at the end of the third year. Assuming the APR, like the general interest rate for money for banks, is 7%. Is this a fair exchange? What if your friend promises you 330 back, which is 100 per, let's just say, year, not money. 100 per year. Okay? See if that's fair. Well, let's use our equation. Let's set it up. First thing I'm going to do, because I don't have it right in front of me anymore, right here, I want to write my equation. My present value equals, it's 1, times, so this is in parentheses, 1 minus parentheses 1 plus I to the negative n, all over I, right? Did we do that correctly? Yeah. Okay. I was just, sometimes I want to make sure the minus and the plus comes first. 1 minus, 1 plus. Right? So let's take some information from our word problem here and see where what goes. Well, a friend who wants to borrow 300 bucks, the amount he's borrowing, that's the present value of the money he's getting. I want to buy a house, borrow 200 grand, that's the present value of 200 grand right now. He's borrowing 300. This is considered your present value. So this side is, it should equal 300. Okay, let's put this over here. Now, what is my R? Yeah, 100 because. Thank you, man. Nice. I love the use of the word. That's his payments. His fixed pay. It's 100 bucks. Boom. So R is your 100 right there. That's one payment. Here's another payment. Here's another payment. It's R. Now, 1 minus parentheses 1 plus. What's my I? We said that's R over K. Well, what is my rate?
0.07.
Thank you. It's 7%. But again, we can't put a percent in the calculator, so we got to get rid of that percent. 0.07. Now, what is K? How many payments is he making per year? He's making one payment per year, isn't he? One payment per year. So when he says he'll pay you at the end of the first year, okay, the end of the second year, whatever, 100 per year. Per year, that's your K. All right, per year. So I'm just going to take that I value right here and put it where it's 0.07 over 1. Close that parenthesis to the negative n. What is my n value? N is what again? So the total number of payments. How many is he making? 3. He's making 3 payments over 3 years, once a year, right? But don't forget we got to negate n. So it's negative 3. All over, well, whatever I is. 0.07 over 1. Now, I know typically if we have a fraction with a 1 on the bottom, we don't have to write it. But 95% or more of the time, these payments are going to be more than once a year. So you just want to get in the habit. That'll be a fraction, okay? For this sake, when you're typing in the calculator, you don't got to put it over 1, but I would like us to get in the habit on that. So we're going to put all this in the calculator right here, and we're going to see if this is actually equal to $300. Before we do that, is there any reason it wouldn't be worth $300? We'll give him $300. He's paying us $300 back. Is there any reason why it wouldn't be?
In time, the rate.
The rate and time might play. Let's look at our answer and we'll discuss that even further. So, there's a lot of fractions here. I see one, the main one. Then in the numerator, there's a fraction, the denominator. I love how y equals I use it forever. So I'm just going to type this in. It starts with my 100 times, in parentheses. I'm typing it in just like I see it. Alpha y equals, I see one big fraction. On the top, in the numerator, is 1 minus parentheses, 1 plus another fraction. And that fraction is 0.07 over 1. I close that parenthesis. Now I need to put my negative exponents. It's negative 3. I'm done with the numerator. I'm down to the denominator. And it's another fraction. And I put 0.07 over 1. I come to the end here. Bang. That is exactly as we wrote it in blue, it is now in the calculator. So want to enter and tell me what you get if you...
262.43160.
Is that what you guys got?
Yeah.
Okay, so let's take a look at this. 262, and if it's money, we'll do two decimal places, which would mean what?
$262.43.
Okay. Is that fair to you? Or is it fair to him? Is it fair to him? Well, I'd do it. If I could borrow 300 and only give you 262 value back, I'd do it all day long. But why is that like that? Because what? It has something to do with 0.07. It has something to do with the payment, like over time. Well, let's look at this. Let's say now, okay, obviously this isn't fair for you. Well, what if now it's 110 for you?
So
You just switch this 100 and the calculator to 110, and I hope you know you don't have to retype it. You just come up here and hit enter. And you just come back here and you wait till that passes all the way over, and you change your 100 to 110. You still only end up very good with 288. So we're going to go here. So now we're going to mark this in our calculator here. Okay, in your notes, make sure you write this in your notes. If R equals 110, then PV is what? 288.67. I think that's a little bit closer to what you let him borrow. You could, and I actually probably would. Now, here's the main question right now, okay? The fundamental idea behind finance. $1 today is not worth more. Or excuse me, $1 today is worth more than $1 tomorrow. You always have your grandparents say, I used to buy bread for a quarter. You can't get bread for a quarter. In fact, there's candy. They used to go with a nickel and get like a handful of candy. Those basic nickel machines, you get the gumballs for a nickel. Now they're a quarter. 50 cents some places. But a quarter. Compared to a nickel, that went up 5 times. The sneakers you buy, that maybe you guys pay close to 200 for. Back in my day, they pay 100 for them, you'd be like, you're crazy. It's 100. Now they're 200. Cell phones you buy, when they first came out, they're a little pricey, but then once everybody got it, if you want for like $150, 200, now they're like 600 if you don't have it. Money always goes up. Okay, so if he borrows 300 and he pays you money back, Donovan, the money he gives you back is only worth 288. Like, if I want to buy something worth $300 now, okay, I could. But if I give it to you 3 years later, you give me 300, I won't have enough. I'll have 288, you know what I mean, value. So I don't have enough to buy something because price goes up with things. All right? Now, what payment will that friend need to make so that it's equivalent to the 300 he borrowed? How would you think you could do that? What would you do? You could solve, okay, but what are some ways you can solve? We can guess. I can just go on my calculator and keep on changing this number at one time.
Yeah.
Raise it up, raise it up, raise it up. But what's an easy way to do something if one number is constantly changing what it equals?
Oh, you put that as X.
And then where do you put the equation? You're right. Like, our payment will become X, but where would I put that? X times 1 minus parentheses 1 plus. Where would that go? So that would, for every X it gives me a different output.
Oh, scat.
No. Why don't I just put it in line 1? And I look at my table. Don't forget that thing. I gotta keep on changing this and look it. This is what I'm doing. Are you ready? Watch this. I'm gonna take this right here. I'm gonna hit enter. And I'm gonna get rid of this. Watch what I do. I'm gonna go deletes, deletes, deletes. I hope I do this right. I am going to take this and I'm going to store this whole thing so I don't got to retype it. I'm going to store this into, let's call it A. So every time I do A, that's what I get, right? So I go to Y equals, instead of retyping it, X goes in front of it, right? Is my payment. I mean, you could retype it. What's in A? What's in it? Is it this whole thing in A up here? Right there. So it's my X value. If you want, you can retype it. I mean, I could retype it and the same thing. But now let's look when I go to my table. First of all, I want to start at 100 because he's going to start off paying me $100, right? So when I look at my table, look at that, 262.43. That's what he came up with. What about when he gave me 110? 288.67. We're good. So where do we have to go so that it actually equals 300? I'm hearing 115. There it is. $201.08. That means, okay, he has to pay me $115 so that in 3 years it's worth $301. So how much is he paying me total back, actual cash? No, think about it. He borrowed $300, and how much is he actually paying me back? $300 what? No, that's the value of it. How much in actual cash? This payment is how much? $115 every time, and how many times is he paying me? 3. So how much is that? He's paying me $115 a year. Yeah, that'd be a total of $345. So what's that mean? That means when I pay him $300, if I want to buy something for $300 and I give it to him, then 3 years later I want to buy that same thing now, I'm going to need $345 to buy it because the cost of living goes up. You see what I'm saying? So when he bought, look it went up $45 and you only borrowed $300. Can you imagine when you got to borrow a couple $100,000 for a house? Well, let me see. This is almost $50, isn't it? And 50 will be half of 100, but it's half of the 100, half of 200, half of 300. So it's 3 halves. So it's 1 half times 1 half times 1 half. 1/6 or maybe 1/8. What do we do? You know how we can do that? Yes, we could. If the change is 45 over the original. 15%. 15%. Which is 1/6, 1 half plus 1 half. Okay? Half the half the half. Okay? Now, did I get that right? It's close enough. Anyways, let's make this. Let's make this crazy. Now, I'm going to show you how to do this once, one way, and then we're going to kind of make the work less every time after this problem. Okay? Let me show you the one way. There's no like real easy shortcut way, but there's a way that you can write less. And I'm going to explain it to you right now. All right? If you want to buy a house listed for $189,000, this might be relevant. You might want to one day buy a house, $189,000. You and your significant other, your spouse, whatever, you guys can work for several years and you save $19,000. You want to put that down, okay? Which means you have $19,000. But you need to borrow the rest of the money from the bank, which means you get a mortgage. A lot of people do. Okay, and the bank lends you that money at 3.95%, but you're paying it for 30 years. It's a 30-year mortgage. All right? 30 years. Which means if you buy a house when you're 30, it's not yours completely until you're 60. Unless you get a habit that you pay it. So every month for 30 years. Wow. You could. There's a big advantage of doing that. Now, what payments are you making per month? So what variable am I solving for here? And it says what payments. What letter back in our equation right here are we solving for? The R. Now I'm going to show you something, because I like you guys. Oh, God, yes. Cuts, go here, go here, go here. If I am solving for R, how do I get R alone here? I'm technically multiplying all this times R, right? So if I want to get rid of it, 1 minus 1 plus I to negative n all over I. This is gone, but I do to one side. 1 minus 1 plus all over I, right? So R really equals this. Fast forward to here. If I want the R, I can say that's my present value divided by that whole mess. 1 minus parentheses 1 plus I to the negative n all over I. I was going to have you write it out like that with all the numbers in it and divide both sides by it and tell you that you can just do this. But you should be able to manipulate your variables and before you can plug in.
So what's the PV 189,000?
I don't know, do you guys agree? Will the PV be 189,000? You are wrong.
Also, we 19,000.
No, that's the money you already have.
That's ours. So, is it in the right 19,000 for 189,000? Oh.
Lends you the balance.
So
How much are you borrowing?
170,000.
Right. Well, it costs 189, right? You're putting 19 that you already have down. So how much left do you need to buy the house? That's your PV. That's your PV. The 170 grand that you borrow, that's your present value. Okay? So, should I pause this and let you guys try and figure out what your pay will be? I'll give you a minute. We got time. We can do it. First off, our present value is 170,000. You guys had that right. All over. 1 minus parentheses 1 plus. What is my I?
It is 0.0395.
Good. This is my R. Okay, and I need to change it from percent to decimal point 0.0395 over the number of payments a year. Well, per month, okay, would be 12. So 12. So 0.0395 over 12. I close this parenthesis, and it's negative 12 times 30, right? All over the I again. Now, when I say all over, this should be its own fraction, okay? So that's going to be over my 0.0395 over 12. If, for conversation's sake, you make these to a fraction and then divide it by that, you'll get a wrong answer. Okay? So and that's a lot. That's a mistake that a lot of kids did last when we worked on our case studies. Typing it in. Typing it in. So let's do this whole mess right now. Alpha y equals, I know I have a fraction. On the top of the fraction, I have 170,000. On the bottom of the fraction, this part, there's another fraction, isn't there? That's when I got to do that right there. 1 minus parentheses 1 plus another fraction, 0.0395 over 12. Kill that parenthesis. Raise the exponent to negative 12 times 30. All over the last fraction. It's the I value. Okay, it's 0.0395 over 12.
I put it the same way, but yeah.
Hold on. That's what it should be.
No, I messed up because I put parentheses around.
Now, I'm going to ask you guys a couple important questions here. Our payments would be, for 30 years at 3.95%, borrowing 170 grand, $806.71. Here's the kicker. Okay, what happens if because mortgage could be 15 years, 20 years, 25 years. Do me a favor. You ladies do a 15-year mortgage. All you need to do is hit enter and change that 30 to a 15. So I come back up here, my whole big fraction, and I gotta make sure I change this 30, okay, up here, to a 15. And then hold on to that. You two guys do a 20-year mortgage, so just change that 30 to a 20. And you do a 25 year. You just change that 30 to 25. Okay? Ooh, some of you guys that can do it, just say doing that out.
I did. So I messed up.
Okay, look, I'll do 25. So you guys do 15 and you two do 20. If I hit enter, that's 892.63. So what we're going to do, this is for a 30-year. So now it is 892.64. We'll round the two decimal places for a 25-year. You guys tell me what would be for 20-year, gentlemen, and then the 15-year, ladies. So, gentlemen, what do we have for the 20-year mortgage?
$1,025.
Okay. Ladies, what do we have for the 15-year mortgage? Wait, 1,253 point. Now look at this right here. If you're getting a mortgage, which mortgage would you rather take?
30.
30, right? Because it's only $800. I mean, look at the difference between your 30-year, what you're paying a month, and your 15-year. But this is the biggest mistake people make. You're only paying this for 15 years about. How much altogether on our 30-year mortgage are we actually paying the bank back over the 30 years? So if we are paying $806.71, how many total payments are we making to the bank? That's, no, we're making 360, 12 by 30. 30 years, 12 months. So do me a favor. Multiply that together. Keep in mind, you are only borrowing $170,000, right? What are we paying the bank back? Wait, 290,415 and what? You are paying $120,000 more because the costs of living is in just 3 years. When that went up from 300 to 345, 30 years. Let me ask you something. Do this. If we're paying $892 a month, but now we're only 25 years, so what's 12 times 25? What's 12 times 25? 300. So now it's only 300 payments. So tell me what that is. 892.64 times 300. Look at the difference just between a 30-year mortgage. That is $20,000 less. You got to have, you should, but you got to pay a little bit more each month. Yeah, that's expensive. Now, all right. It also helps you have more money to put down. What if you had $50,000 and you have to borrow 170? You know what I'm saying? You had to borrow 139. Now, do me a favor. What about this one? If I'm at 1,025.69, okay, at 20 years, how many payments is 20? It's 240, right? Do that. Do what that is.
246,
Okay. 246, what?
165.67.
Wow. That's $45,000, just about $44,000 less. That's a lot of money. Now, this one, no one said they wanted to do 15 years. What is 1253.21 times, now 15 times 12, what is that? What is 15 times 12? 180? Is it? You did it? 20. So now you're only making 180 payments. Here, look at, you were making double that, 300 or 360. 225, what is it? 225. 77.8. Look at the difference. All of you guys said 30 years. Yeah, it's cheaper per month. That'll save you for the month, but over your lifetime, that is, what is that? A difference of what? $65,000? That's $65,000. Now, you need to have the money to cover that. If you and your wife or you and your husband or whatever are working and you both make $2,000 a month, and you make $4,000, you can probably swing $1,200 a month. Don't forget, you got grocery bills, you got, taxes, you got car, maybe you're making car payments. Car payments work the same way. Okay? So this is a skill that a lot of people, when the bank works it out for you, It tells you, oh, if you get a 30-year, they're going to say you're only paying $806 a month. But if you go 20 years, $1,025, you're like, I don't know if I want to buy the house. Well, what if it's 30-year? Look, you only pay $806. You're like, we'll take it. They don't sit there and say, you're going to give us another $40,000. You know, I mean, they just throw this in front of your face. You can. What are you going to guess? You tell the guy, say, give me a calculator. Get out your phone and guy. He's not going to say no, because that's what's going to do, lose your business. The bank makes some money, too, on this. That's the business of banking. But this is a skill, I'm telling you, that when you walk away from, you're going to remember it when you start buying it, when you rent it. Think about, if my wife and I rented that apartment for like 3-4 years, maybe even longer, and we were paying $800 a month, and then we're like, man, we calculated it. For 4 years, 12 months a year, it's 48 payments, 48 times 800. Go ahead, tell me what you got.
38,400.
38,000?
Yeah, 400.
That's how much we spend on renting. We don't own it. We're paying it like a mortgage to buy it. We just gave someone 38 grand over the course of like that many years. So we'll start future value next lesson.